And now let me show you the thing that I just blew right past you that's even cooler about RANSAC. All right, so how big does n have to be? Well, we gave you this equation, right? N is greater than 1 minus log of 1 minus p over log blah, 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 blah. Fine. Look at that function. What's p? P is the probability of success. What's e? The percentage of outliers. What's s? The number of points in your minimal set. Notice what's not in there is the number of points in the image, or the number of features. So you may have 10,000 or 1,000 or 100 or 500 putative matches, let's say, for a transform. Remember all those red lines that were going back and forth? The number of samples you have to draw has nothing to do with the number of possible matches that you're looking at. It only has to do with the percentage of wrong ones and the size of the minimal set and how sure you want to be that you got there. So that's really great, because that means that the whole algorithm is pretty scale invariant with respect, or I should say size invariant with respect to the number of matches and the number of hypothesized points that you have. And that actually is part of the reason that it works so well. All right, so let's illustrate that here. Let's suppose I've got two pictures, and let's just, for the sake here, assume that there's just a translation. So I'm just looking for 1 point matched to 1 point. And the system has proposed a whole bunch of matches. So there's one, and there's another, and there's another, and there's another. And all of these, you and I know are actually correct, right, Megan? Right, okay. But it also proposed this one, and it proposed that one. And those are not right. But of course, only you and I know that, and 9 million people watching. Okay, but the computer, because it's not so smart, it doesn't know that. So showing you how RANSAC works, what we do is we select one match. Here's one, that blue one right there, and we just count the number of matches that agree. So 1, 2, 3, 4, 5, okay, great. And then we take a look at the ones that don't agree, 2, so 5 out of 7, that's 70% or whatever. 5 out of 7 of them agree, great. Okay, so we got to do it again. We pick another one, try that one, count the ones that agree, 1, 2, count the ones that don't agree, 1, 2, 3, 4, 5. That's 2 out of 7. Last time I checked, 2 out of 7 is way lower than 5 out of 7. So you would basically say, aha, here is the set of matches that are right. Now, I've got 5 points matches for doing a translation. How many points does it take to do a translation? It only took 1. So should I just pick 1? No. I have 5 translations here, all of which are a little noisy. So what do? I just take the average. I could even do sort of a robust average, but you probably don't even have to at this point, right? You just have to make sure you have enough points left in order to take the average. So basically what you're doing is you're going to use RANSAC in order to select the points that you believe actually come from the Gaussian noise model. Get rid of the outliers, and then you do an average, which is the right thing to do when you have points from a Gaussian noise model.